Greetings, video fans. Today I'm going to play a request for you. Several viewers have asked that I do a little technical video here on power transformers. So Rusty and I cooked one up for you, and I hope you enjoy it. Rusty, if you promise to do some good camera work, I'll play tennis ball with you. Ready? What a good boy. The power transformer is really the heart and soul of any amplifier and generally the most expensive single component. So let's take a look at them today and see if we can figure out how they work and how we can identify the characteristics of different transformers that will make them either right or wrong for our amp. Okay, let's start out real small here. This is one of those transformers that you can buy at Radio Shack. And you see on one side there's two wires coming out and it says primary 120 volt 60 cycle, which is normal house current in the United States. The other side has three wires coming out and it says secondary 3 amps 6.30 6.3 volts. Well, let's take a look at a diagram to see how this is made and how it works. Okay, here's a diagram of that little Radio Shack transformer. On the primary side, we had the two black wires that we connected to 120 volts of alternating current. Transformers only work on alternating current. If you connect this up to a 120 volt battery, nothing will be available on the other side. Because for it to work, it requires that the magnetic field vary in the transformer in this particular case at 60 cycles per second. There is a iron core in the transformer to accentuate the magnetic field and to boost the effect here to the secondary. Now, all transformers, the ratio between input and output is based on the turn ratio. If we have 100 turns of copper wire on this side of the core, and we have 10 turns on the other side of the core, our ratio will be a 10-to-1 turn ratio. That means that the input voltage, if it's 120 volts, will result in a 1/10 of that amount output on the secondary. So 120 divided by 10 is a 12 volt output. Now a lot of transformers come with a center tap. And what that is it's a third wire on the secondary side that splits the difference here. So instead of 10 windings, the center tap has 5 here and 5 here. That would give this one a 5-to-100 ratio, which would be 1/20th of the 120 volts, which gives us 6 volts here and 6 volts on the other side of the center tap. So if you want 12 volts, you would hook up to these two wires. If you want 6 volts, you would hook up to either these two or these two. Now the important characteristic of transformers, besides the voltage that they put out, is how much current can flow through the transformer before the finer or thinner wires in the transformer actually burn through. And once that happens, the transformer is ruined. If any of you have had this happen, you know it's a very expensive proposition to replace them. So we have to be very careful and note what the rating is on the transformer. On this Radio Shack transformer, it's right here. It says 3 amps. So if I hook these wires up in any configuration, I am limited to a total of 3 amps flowing from the secondary of this transformer. If I exceed that, the transformer will probably fail. Now let's move on to the far more complex type of transformer that we find in the guitar amplifiers that we work with. As you can see in this diagram, and this is from a Fender Deluxe Reverb amp, and that's going to be the one I will use as an example for this discussion. The primary looks about the same as in my drawing. Here it has a fuse and it has an on-off switch, which is real typical. We have here the iron core of the power transformer. And then on the other side, you see we don't have the simple two wires with the center tap. We've got a bunch of windings over here. Let's take a look at them. Down here, these will be the wires that we will use for the filament voltage for the 6-volt filament tubes. And that'll be the 7025s, the 12AX7s, and the 12AT7s, and the 6V6s. Now up here we have the filament windings for the GZ34 rectifier tube. You see that's the filament right there. This will be a 5-volt winding. And then down here we have the high voltage windings. And these will be putting out 330 volts of AC to the plates of the GZ34 rectifier. And true to form, I notice a center tap right here and a center tap down here for the 6-volt winding. And these are generally grounded. See the little triangle at the end? The center taps of the 6-volt and high voltage windings are grounded. You notice that the 5-volt does not have a center tap. One other thing that you may see in guitar amplifier transformers is a tap right here for the bias voltage. And that is coming out here and is going to go up to the grids of the output tubes to bias them. Now, I have another video in which I describe that process in detail. I also have another video in which I show you how to figure out the winding ratio of a transformer. But today we're simply going to address how the transformer works and what values about it that we need to be concerned with when we're picking one for our guitar amplifier. Now let's say worst case scenario, something terrible happened and the power transformer in our Fender Deluxe Reverb just went up in smoke and we have to replace it. First off, you better find out why it failed and solve that problem, or your new one will probably burn up also. Okay, just simply replacing a part is not always expedient. You first must figure out why the first part failed. Now with that problem solved, we need to take a look at our Fender Deluxe Reverb circuit and figure out what are its characteristics and how will they determine the exact model and type of transformer that we're going to buy to replace the one that failed. First off, if you notice right here, Fender calls the power transformer TR1. And then you come over here and take a look, and that's for export. That's a 240 volt primary. This is going to be the 120 volt primary that we're used to, and it's 125 P23B. Now there are places on the internet like Triode USA and Hammond where you can go and just simply ask for a direct replacement for that transformer. And that's probably what a lot of us would do. But for those of us, like some of you and me, I like to know what I'm getting. And therefore, let's double check and see if the transformer that they say we need is really going to be appropriate for our purposes. Okay, let's take a look at the tubes that the transformer will be feeding. Number one will be the rectifier tube. And it will be provided the 5 volts to its filament as well as the high voltage, and it is a GZ34. We also see that we have a pair of 6V6 output tubes, and then as far as the preamp tubes, reverb driver, tremolo tubes and all, we're going to have 3 7025s, a 12AT7, and a 12AX7. Now, since we said that current is what can make or break a transformer, let's see what the current requirement is of our GZ34 rectifier. And I see that it's 1.9 amps. So I'm going to write that down. Okay, my filament, 5-volt filament windings on my new transformer must have at least a 1.9 amp capability. And to play it safe, let's go a little above that and say at least 2, 2.5, maybe even 3 amps. Okay, that's the requirement we'll have for the filament windings for the 5-volt output from our new transformer. Now let's look at what the current requirements are for the output tubes. And 6V6s, each one is going to require 0.45 amps to flow through the 6-volt filament of the 6V6. So with 2 of them, I'm going to have 0.9 amps minimum in my 6-volt winding of the transformer. But I've got some more tubes to consider. So let's write down the 0.9 and then move down to the other tubes. Okay, the preamp, the tremolo, the reverb driver and all. The 12AX, 12AT, 7025 family of tubes require 0.15 amps per triode. Now, most of you realize there's 2 triodes in each of these tubes. So if you're using both sides of the tube, you'll need 0.3 amps for each 12AX7 that you fully utilize. If you have 6 SC7s, old pentodes, it'd be 0.3 amps. Okay, so you see how the chart works. But in this case, these are the family of tubes that I need for the rest of the circuit of my Deluxe Reverb. All require 0.15 amp per triode or 0.3 amps per tube. So let's add it all up here. We've got 3 7025s at 0.3 amps because all 3 are fully utilized. That's 0.9 amps. 2 12AT7s at 0.3 gives me 0.6. 12AX7 at 0.3 is 0.3. 2 6V6s at 0.45 each, 0.9. Okay, 2.7 amps will be the requirement for the 6-volt filament winding of my new transformer. Let's go above it. Let's say at least 3 amps. Now let's look at the GZ34 that we have here. It's only 1.9 amps of filament current. This is the 5-volt winding. So we want to see a 5-volt winding in our new transformer of at least 1.9 amps. Let's say at least 2, if not more. So let's take a look at what's available and what Triode tells us is the proper transformer for our Deluxe Reverb, and let's see if what they've told us is true. Okay, now when we look at the diagram of the recommended transformer, there's 2 styles of transformer. One that sits up and just mounts flush to the surface. This will be the chassis down here, and the transformer is just going to bolt to the surface of the chassis and protrude completely up and away from it. Now the other type of transformer is one like this that mounts into the chassis down flush with the iron core, the laminations, and would bolt here and here to the chassis. So you'd have to cut a square hole out of your chassis so that this could sit down in it. Okay, so step 1, we need to determine if our Fender Deluxe Reverb needs a bottom mount transformer or a flush mount transformer. Let's say it's bottom mount and that this one then is the correct configuration. So we can continue now and take a look at the specifications of this recommended transformer. First thing I notice is the primary of this recommended transformer is more complicated. And then I take another look here and I see that it's because it's suitable for both 120 volt AC and 240 volt AC. If you're going to use this transformer in the United States with 120 volts, you would use the white and black wires as your primary connections. If you were going to use this in Europe, you would connect to the white and the black-white as your primary connections, and then connect these 2 wires together so that the 240 ran all the way through both windings instead of through only one of the windings like the 120. So now let's take a look at the outputs of this transformer and see if they're going to work for us. First, we have the 5-volt winding here that's going to provide the filament voltage for our GZ34 rectifier. And as you recall, the GZ34 required only 1.9 amps of current. This is capable of flowing 3 amps all day long with no trouble, so we far exceed the minimum requirement for a GZ34. This winding of the transformer is excellent. This is terrific for our purpose. Let's look at the 6-volt winding. This is going to be for the 6V6s and all the other tubes. We needed a minimum of 2.7 amps, and we have 3 amps. Okay, so it does exceed the minimum that we needed. It's not with the margin that this one exceeded, but these transformers tend to be pretty well over-engineered, where if they say 3 amps, it could probably flow 4. So I can just tell you from experience, this will be enough margin for us, and I believe that this winding will serve our purposes quite well. Now let's look at the high voltage winding that's going to go to the plates of the rectifier. Remember, we needed around a 50 or 60 volt output for our tube biasing, and we've got it here, a 50 volt bias tap, which is great. We've got a center tap here on our high voltage output, and we've got a center tap on the 6 volt filament output. If you remember, we needed to have those center taps to go to ground. So far this satisfies our needs. Now there's one other parameter here that has to be discussed on the high voltage winding. Actually, there's 2 things to discuss. The first is going to be the B+ voltage. As you notice, for the Fender Deluxe Reverb amp to work properly, there's supposed to be 330 volts AC applied to each plate of the GZ34, which means that our replacement transformer should be capable of putting out 660 volts AC. And as you can see, it does put out exactly that amount. And the second thing is the plate current that this transformer is capable of producing. The largest consumers of that current by far will be the plates of the 6V6 output tubes, which when biased will probably flow about, say, 35 milliamps of current each for a total of 70 milliamps. The remaining tubes, the 7025s and 12AX7s, draw very, very little plate current, say 5 milliamps each, which is generous. Since there are 6 of those tubes at 5 milliamps each, we'll say about 30 milliamps, plus the 70 here will give us 100 milliamps of plate current. And since the transformer is rated at 120 milliamps, we ought to be in good shape. So, based on our own determinations, by looking at the schematic of this amplifier, figuring out the demands for the tubes, it appears that this particular transformer, as recommended by Triode USA, would fulfill our needs quite nicely for our Fender Deluxe Reverb amp. Now, let's take a look at a gigantic transformer that I removed from a Baldwin organ amplifier. And let's see if it has all the windings and everything that we need to make a guitar amp. First off, and I marked these, when I took this out of the chassis, I was lucky enough to have the wires intact so I could tell where they went and tell what they were. Okay, this is going to be to the 5U4 plate. So these are the high voltage outputs, and remember we wanted to have a grounded center tap, and there's the one that was grounded. So we've got our high voltage. Let's take a look here. We've got our 6 volt output here with the center tap that we can ground. We've got a 5 volt output here for our, in this case, a 5U4, so I know this must be able to handle at least 3 amps. And last but not least, here's the primary that we needed for 110 or 120 volts. So it would appear that this gigantic, and I'm going to say 6 or 7 pound transformer, would be very usable to make a guitar amplifier. God knows you'd probably need a hand cart to haul the thing around and hernia insurance, but you would never be at a loss for current, I don't think. Because as another rule of thumb, usually the larger and heavier the transformer, the more current it can carry, and the better it will perform in the amplifier. You get a little scrawny, wimpy little transformer, and it's sort of like having somebody with a heart that's too small. They're never going to be an Olympic athlete. Okay, the bigger and more iron you have in the transformer, and look at these laminations. I mean, good Lord, you know, this thing is just a marvel of nature here. I cannot imagine that you could come up with any sort of amplifier that this thing could not power quite well, and maybe a couple arc welders on the side. So now we've gone from the ridiculous to the sublime, okay? We've covered, I think, all the aspects of transformers that, for just the practical knowledge that you'll need to make informed decisions. And I hope that you found this helpful. And that you'll join Rusty and me for future videos. Hopefully you've already subscribed to our channel. If not, I wish you would. I know Rusty cries at night in his doghouse because he knows there's people out there who haven't subscribed yet. So unless you enjoy cruelty to animals, you will subscribe to this channel. But most of all, he and I hope that you all will stay healthy and stay tuned, because we want to see you again in the near future. Bye for now. Rusty's trying to figure out which tennis ball he wants to play with. Come on, Rusty, pick one. Hey, Rusty, are you ready to work on this video? Guess not. Rusty, if you promise to be a good cameraman, I'll play tennis ball with you. Oh, my Lord. Didn't even get a chance to bounce.